Yes. Assalamu alaikum students. This time I am welcome you in lecture number 4 on differential equations. It is lecture number 4 on ordinary differential equations. You have to go through first lecture number 3, then you should go this lecture. Here we will discuss the variable separable method. I have already told you we have now different methods for solving linear differential equations of first order, differential equations of first order and first degree. We have different methods, and first method with which we start is the variable separable method. What is this variable separable method? I will discuss a little bit about it. If a differential equation can be put in the form such that all x terms, x functions, or functions of x, all functions of x with dx and functions of y with dy are expressed separately on one side. That is, if it can be put in the form, it is your function of x dx is equal to function of y dy. We separate the two, function of x with dx on one side and function of y with dy on another side. Then what is the solution? It is the method of solution that I am giving you. Then solution will be integral of fx dx plus integral of gy dy. If we write only this solution, it is incomplete. We should add plus c on one side. Add the constant of integration on one side necessarily. Then this solution is this is complete general solution, or complete integral, you may say. Complete integral you can also say. Well, in other words, we can say if you can put a differential equation in this form, if given differential equation can be written as some function of fx dx, say f2 is a function of y dy is equal to 0. If we can put it in this way, sometimes we can put in this way. In this way also we have written all the terms of x, function of x with dx, and these are the functions of y with dy. In between them you have plus, that is that hardly matters. You can transpose this to right side, or you can write the integral here also. You can write solution is integral of f1x dx plus integral of f2y dy, and add constant of c on one side. So I shall put a note here for you. It is very important. That is constant of integration. Constant of integration must be added on one side, only one side, not two sides. On one side, then solution is general. that is complete solution. Complete solution. Otherwise it is not a complete solution if you do not add the constant of integration. It should be added only one side, or one. If you add on two sides, then that will also merge to one single constant. So it is only to be added on one side. Now let us have the application. Application part is very important. I have picked some questions from different books. From different books, you have the books prescribed in your syllabus. I have taken the questions from that, and from some textbooks, from reference books. So I will show you some mixed problems here, so that each of you can do the problems at your places from your each book, whatever book you will have. Let us have some applications on this. Now we are coming to application part. This will be applications on questions where we can apply this method, variable separable method. This is actually the first method. So let us have now applications. Applications. I will take a first. I have taken questions from this. I will take a first question. Solve the differential equation. Solve differential equation 1 plus x square dy is equal to 1 plus y square dx. This is the question that I want to solve. 1 plus x square dy is equal to 1 plus y square dx. Let me look at this problem. Can I separate the variables here? Can I separate the variables? Yes, I can separate. I can write, this implies that this is my x function, it is dx, this is y function, it is dy. I can write dy by 1 plus y square is equal to dx by 1 plus x square. Yes, that means variables are separated now. We have separated the variables. When variables are separated, you can write the solution. The solution is integral of dy by 1 plus y square is equal to integral of dx by 1 plus x square. And what is this integral? You know, it is the integral of tan inverse y, because derivative of tan inverse y is 1 by 1 plus y square. So it is tan inverse y is equal to tan inverse x plus c. You have to add the constant of integration. So you can write it in this way also, tan inverse y minus, if you want to further simplify it, you can do it. It is tan inverse y minus x by 1 plus xy is equal to, let me choose this c, this is arbitrarily constant, let us choose this tan inverse c. No problem. It is at your disposal, arbitrarily constant. You should choose anything, but it should remain a constant, because it is unknown constant, arbitrarily constant. You can choose as per your requirement. Sometimes you may choose it log c, you may choose it tan inverse c, whatever you require to just simplify the problem in a better way. This and this goes. I can write solution is y minus x by 1 plus xy is equal to c. This is the solution. This is the general solution of the problem, and in simplified form. Well, this was the one problem, this application. I take one more application on this. Let me have application number 2. It is solve the differential equation secant square x tan y dx plus sec square y tan x dy is equal to 0. This is also one problem. Let us solve it. Can we separate the variables? We have to first look at this. Can we separate it or not? Separation here is very simple. This implies you can write it secant square x tan y dx is minus times sec square y tan x dy. Now this is your dx, this is x term involving x, and here this involves x. Similarly, you have the y term, this is y term, this is here y term, this is dy. So you can take the x terms on one side with dx and y terms on other side with dy. You can write this as, this is secant square x dx, taking this tan x down, is equal to, this is minus secant square y dy and their y term by tan y. So you can write variables got separated. You could separate the variables easily. When you have separated the variables, you can integrate this on both sides. This is integral of sec square x by tan x dx, integral of sec square y tan y dy. Let us add the constant of integration. Now what is this? This is f dash x by fx form. Derivative of tan x is sec square. You know, if you have an integral like this, integral of f dash x by fx dx, that is when numerator is the derivative of denominator. Numerator is the derivative of denominator. Derivative of this is this. So it is log of denominator. It is log of fx. So here you can write it as log of tan x is equal to minus log of tan y plus c. You can write it is log of tan x plus log of tan y is equal to c. Do you follow? I am just taking the log terms on one side. This is log m plus log n. Log m plus log n. It has base e, understand? Because we take in calculus the usually base e. If it is not base e, then we try to get the base e, then differentiation. So we can have, when we differentiate this, base is e. Log of m plus log n, log of mn. This is log of tan x tan y. Log m plus log n is log of mn. Now c is at your disposal. You can choose it log c. Log cancel. So solution is tan x tan y is equal to c. This is the solution of this problem. Tan x into tan y is equal to c. In any way, this was your problem number 2. I have already told you, I have picked up these problems from your different books, textbooks somewhere, engineering mathematics books. From that, there are engineering mathematics books available. From that I took some questions, and your text and reference books. So I sum up these questions so that you will not find any difficulty. You can do the rest. Then we have problem number 3 that I took here. Problem number 3 I write, it is solve the differential equation. Solve dy by dx. It is e raised power x plus y, then plus x square e raised power y. E raised power x plus y plus x square e raised power y. This is your differential equation. Let us see, can we separate the variables here? You can write it is dy by dx is equal to, I can split this by indices rule, e raised power x e raised power y plus x square e raised power y. Okay, this I can write dy by dx is, take e raised power y common, this is e raised power x plus x square. Now I can easily separate the x terms with dx and y terms with dy. I can write it is as dy by e raised power y is equal to x square plus e raised power x dx. What does this mean? That means variables got separated. Variables are separated. So when variables are separated, you can integrate. You can write it is integral of e raised power minus y dy is equal to integral of x square plus e raised power x dx, right, plus c. Now what is it is integral? It is e raised power minus y by minus 1, because derivative of power is minus 1. In integration we write this down in the denominator. It is integral of x square dx plus integral of e raised power x dx plus c. This gives you minus e raised power minus y is equal to, what is the integral of this? It is x cube by 3. Integral of e raised power x is e raised power x, and differential of e raised power x is also e raised power x. So it is e raised power x plus c. So this is your solution of this differential equation. Do you follow? Very simple. When you have the variable separable, sometimes you have some equations, differential equation, where you have to reduce the differential equation into variable separable. We will also deal some questions on that. Let me first solve these. Suppose we have a question here. This is a fourth one. Let us solve the differential equation dy by dx is equal to e raised power x minus y plus e raised power twice log x minus y. It is this. Solve this differential equation. Let me see, can we separate the variables here? It is dy by dx. This is by indices rule, e raised power x, e raised power minus y. This is plus e raised power 2 log x into e raised power minus y. Yes, I can take it out. So it is dy by dx is e raised power minus y out, e raised power x plus e raised power twice log of x. That means you have written this as the product of two functions. One is function of y, function of x. You can separate now. This is equal to dy by e raised power minus y is equal to e raised power x plus e raised power, you can write it m log n. It is log of x square dx. So here also variables got separated. Variables got separated. Now you have a formula. If you remember, what is log of m raised to power n to the base e? You have log of, it is like this. It is this. When we have something e raised to power log of m to the base e, it is log of x square, e raised to log of x square to the base e. The log has its own base e. When it is like this, it is simply m. You know it is m. We are using this formula infrequently. So this is actually your e raised to log x square to the base e, because log has its own base e. It is e raised to power something, so it is x square. So this is your e raised power y dy is equal to e raised power x plus x square simply dx. So variables got separated, so you can easily integrate now. You can write it as integral of e raised to power y dy is equal to integral of e raised power x dx plus integral of x square dx plus c. This is integral of, this is e raised power y is equal to e raised power x plus it is x cube by 3 integral of x square plus c. So this is your this. If any student, actually we say that this integration is actually the language of differential equations. Some student was asking me that this differential calculus is the application of integration. Of course, it is application of differential, it is integration. It is application of differential integration, of course, because we cannot do without integration here. Remember one thing, that in every type of this differential equations, whether it is the ordinary differential equation or it is the partial differential equation, take the integration as language. Integration is a language. That is why I have given you some lectures, video lectures. Those are available. Maybe 3 or 4. I will be sharing more of that. It is the basics of integration. If you have any problem in integration, then you should go there. Go through those 3 videos and revise there what is the basics of integration. If a student has integration very strong in from 12th class, then he has no problem. If some students are weak in integration, then you should revise integration fully integration, and then you can sit in the class of differential equations. How to solve a differential equations? It involves fully the method of integration. To take integration as the language of this differential equation. Well, let me take one more problem here. This is your fifth problem I am taking. Solve the differential equation dy by dx is equal to x times, it is 2 log x plus 1 by sine of y plus y cos y. Very simple. This is a question is because this is a function of x, pure function of x. This is function of y. I can separate the variables easily. I can write this is sine y, y cos y. Okay. dy is equal to 2x. Write it 2x log x plus x dx. So variables you have got separated. Variables you get separated. So you can integrate. This is integral of sine y plus y cos y dy. It is integral of 2 is a constant, integral of x log x dx, integral of x dx. You may add constant up here. If you add it by after that setup, doesn't matter, no problem. Integral of this implies integral of sine y dy plus integral of y cos y dy is equal to twice integral of, I will go this way here, by parts I will do here. I will take this as u, this as v. Product rule for integration. Not this for v, because log function we take for differentiation. We don't know it is differentiation integration directly. This is your u, this is your v. Isolate rule. I will just write here how to integrate this x log x dx, taking u is equal to log x, v is equal to x, and use the integral u integral of v minus whole integral differential of u with respect to x integral of v, then whole to be integrated with respect to x. This is your product rule for integration. I am just revising it what you did in your class 12th. Well, it is your u is your log x, then integral of x is x square by 2 minus whole integral, differentiation of log x is 1 by x, integral of x is x square by 2. What you get here, it is to be integrated with respect to x. It is the integral of this thing. It is integral of this. This is integral of this one. Then plus integral of this x square is simply x square by 2 plus a. Okay, here also I will go this way. I will treat this as here. This I will treat as v. This is your u, or you may write isolate. How you do there? Isolate. I is inverse, L is logarithm, T is trigonometric. You do there isolate. You take I inverse function, L is log function, A is algebraic, T is trigonometric. So you take this as u, this is v. Okay, then you go. Now what is integral of this? Sine minus cos y plus u as it is, that is y. Integral of cos is sine y minus whole integral. Differentiation of y with respect to y, it is 1. Okay, then integral of cos y is sine y dy. I am doing here the same thing that I did here, product rule, but take the choice properly. First comes the algebraic, so take this u, then trigonometric, take it v. This is your this setup. It is now 2 log x, x square by 2 goes, it is simply x square log of x, 2 goes, x square log x, minus, it is this 2 and 2 will also go, integral of x log x dx, simply. It is x dx, this 2 and 2 outside, this remains here x dx, then you have plus x square by 2 plus c. Okay, now look here, it is your minus cos y, this is plus y sin y, integral of sin y minus cos, this will be plus cos y, then this is x square log x minus x square by 2 here, plus this is also x square by 2 plus c. Well, this goes, the solution is y sin y is equal to minus x square by 2 plus x by 2 also goes x square log x plus c. This is the solution of this differential equation. Y sin y is equal to x square log x plus c when these two terms get cancelled. Okay, very simple, but you have to in between take the product rule for differentiation. Let me take one more problem. It is sixth one. It is solve the differential equation x square minus y x square, x square minus y x square dy, then plus y square plus x y square dx is 0. X square minus y x square dy plus y square plus x y square dx is 0. Solve the differential, very simple. I can take here x square term common, 1 minus y dy. Here I can take y square common, 1 plus x dx, it is 0. I want to apply the method, this variable separable method. This you can write x square 1 minus y dy is minus y square 1 plus x dx. Now take this is x term, I will take this with this, and y I will, it is 1 minus y dy by y square is equal to minus times 1 plus x by x square dx. So here you can say variables got separated. So we are happy at this setup when variables are separated, because we can directly integrate it. This implies integral of 1 minus y by y square dy, integral of 1 plus x by x square dx. This you may write constant of integration. This is integral of 1 by this, it is y raised power minus 2 minus y by y square, it is 1 by y dy is equal to minus times, this is 1 by x square, x raised power minus 2 plus x by x square is 1 by x dx plus c. Well, it is integral of y raised power minus 2 dy minus integral of 1 by y dy is equal to minus integral of x raised power minus 2 dx integral of 1 by x dx plus c. Now you can integrate. When you integrate this will be your y raised power minus 2 plus 1 minus 1 by minus 1, it is minus log y is equal to minus x raised power minus 1 by minus 1, this is plus log x plus c. You can further simplify it or leave it there. You can also simplify it further. You can simplify it is minus 1 by y minus log y minus plus 1 by x, this plus log x plus c. then you can simplify or write the solution is this. Let us take one more problem. 7th one. Suppose we have to integrate, solve the differential equation dy by dx tan y is equal to sine of x plus y plus sine of x minus y. How we go? Here you see that this x plus y and x minus y is somewhat in implicit form. Can we try to get it in explicit form? This I can write dy by dx is tan y is equal to, using this formula you know from your lower classes, sin p plus sin q. Yes, do you remember what is it? It is twice sin p plus q by 2 sin p minus q by 2. No, it is sin p plus q by 2 cos of p minus q by 2. So accordingly you can write it, it is twice sine of x plus y plus x minus y by 2 into cos of x plus y minus x plus y by 2. We have used this formula, sin p plus sin q twice sin p plus q by 2 into cos of p minus q by 2. This is your dy by dx is tan y is, it is twice sine, it is simple x, this is cos y. Now you can write this, this is your tan y dy by this cos y is equal to twice sin x dx. Tan y cos y down to here, sin x dx goes here. Variables separated. So variables got separated. What is this integral? Well, this is your integral of 1 by cos tan y sec y dy is equal to twice integral of sin x dx plus c. What is integral of tan x sec y? It is sec y, because sec x tan y, sec x tan x is the derivative of sec x. So it is integral of tan y sec y dy is sec y. Sec y is equal to, it is minus twice cos x, because integration of sine is minus cos, minus 2 cos x plus c. So this is the solution. Well, dear students, I have just shared some applications on this variables separable method, how variables are separated. I will be giving some more questions to you which are a bit complicated than this, and some questions where we reduce the differential equation in the form of variable separable method. Then we will go other methods, homogeneous, extra, and you revise this patiently. You should also do questions. It is very important to do questions from the books that you have in your places. You may have the textbooks, you may have the reference books, but not only you will confine to these questions only, to some questions more and more. I wish you success in this field in differential equations. Thank you very much.